All right, so we're going to talk about reference angles next. For any angle theta whose terminal ray does not lie on the x-axis or the y-axis. So if it ends on an axis, then we're not talking about those. But as long as its terminal ray is somewhere else, the reference angle is, let's see, let's try to make this a little bigger here. Okay, the reference angle is the positive. So reference angles are always positive. Acute, so it's always less than 90 degrees, angle formed by the terminal ray of theta and the x-axis. Not the y-axis, the x-axis. Always the x-axis. Okay. And we have a notation for the reference angle. We use theta, if we're talking about the angle theta, and we put this little caret symbol above it. It's actually called a red theta hat. So we use theta hat to denote the reference angle of theta. That's the way we write it. All right, so we're going to start by just drawing some angles and finding their reference angles. All right, so we're going to sketch the angle and then we're going to name its reference angle. So the first thing we're going to do is find 40 degrees. Well, that would be in the first quadrant. Okay. So there's 40 degrees. I'll label it like this. Okay. And its reference angle, we would need to find the angle that goes between its terminal ray and the x-axis. Well, that's just right here. In fact, so I'll label it theta hat. Theta hat is equal to theta in this case, right? In fact, any first quadrant angle, its reference angle will just be itself. So theta hat equals 40 degrees in this case. And just a little note, first quadrant, maybe I'll write that in a different color so it doesn't match the other one. First quad angles are equal to, or at least coterminal to, their reference angles. Maybe this would have been 360, 400 degrees, and it would have landed there, but its reference angle would still have the same terminal and initial side. All right, so let's do a little bit more interesting one. How about 160 degrees? 160 degrees. So first you need to figure out where that lands, right? We know that all the way to here is 180. So it's a little bit less than that. And where is its reference angle? So terminal ray and the x-axis. So its reference angle is right here. Okay. And what is the measure of its reference angle? How much does it equal? Now, again, there are formulas you could memorize. Well, if it's in the second quadrant, then this is the formula to calculate it. And if it's in the third quadrant, then this is the formula. But I don't think we need to overcomplicate it. You have common sense. You know that all the way to here is 180. So if this is 160, how much further do you have to go to get to 180? 20, right? So it's a 20-degree angle. I could tell you it's 180 minus whatever, minus theta, if it's in the second quadrant, right? But you could also just, I mean, do you want to memorize 3 different formulas or do you want to just use some common sense? So let's try 215. Where does that angle land? So this is 180, this is 270, so it must be in between there somewhere. So here's my 215, right? I mean, I could label it like this, but then that gets a little cluttered from when I want to try to, oh, I erased the whole thing. Not meant to do that. When I'm trying to show where my reference angle is. So where is the reference angle? Terminal ray, x-axis. It's right here. And what is its measure? How big is it? Well, if this is 180, how much further did we go? To get from 180 to 215 is 35? 35. So again, I could tell you if it's in the third quadrant, then you're going to do theta minus 180. Do you really want to memorize? Yeah. You can answer this question, yes, if you want to. That the second quadrant is 180 minus theta, but the third quadrant is theta minus 180? Or do you want to just look at it and realize you need to do this minus that to figure out what's here? Okay. It's up to you. All right, there's 3 more here. I want you to try. Graph the angle, draw in where the reference angle is, and calculate how much it is. Remember, reference angles are always positive. Give it a try. All right, how did it go? So graphing 325 would be here in the 4th quadrant. Its reference angle would be right here between the x-axis and its terminal ray. And since I know all the way around is 360, how much further do I need to go if I'm at 325? So that would be like 360 minus 325, which is 35. Okay. Now we have a couple negative ones. So negative 250 going this way, this would be negative 180. This would be negative 270. So I'm a little bit short of that. Remember, the reference angle is always between the terminal ray and the x-axis, not up here, down here. So once I draw that in, I'm thinking positives, right? If this was 250 and this was 180, then I'm going to do 250 minus 180 to figure out the difference, and it would be positive 70. Reference angles are always positive. Okay, and then last but not least, negative 130 would land me over here in the 3rd quadrant. Reference angle would be here. The difference between the 130 and the 180 is 50. So that would be its reference angle. Now for the challenge. We did it in degrees. Now we're going to do it in radians. And we're going to do it in radians without converting to degrees. The moment has come where you really need to start thinking in radians. Okay. I know it's a little painful for some of you at first, but the more you kind of follow the procedure, take your time, but force yourself to think in radians, the better off you're going to be. And in 2 weeks, maybe max, you'll be like, oh gosh, I can do this. And I am thinking in radians and I never want to convert it to degrees. So that's where we want to get to. All right, so let's start with 9 pi over 5. Let me zoom in just a little here. So remember how we did this in the last lesson? We looked at the over 5, and we want to convert pi to over 5 and 2 pi to over 5. So 5 over 5 is 1, 10 over 5 is 2. Halfway in between, I mean, that would be an odd number, so it'd be like 7.5 pi over 5. But it gives us a point of reference so that when we go to figure out where the 9 is, it's going to be past this over here. Oops. So my 9 pi over 5 angle is here. Now its reference angle will be right here between that terminal ray and the x-axis. And if I'm going to try to figure out what that's equal to, you can do this. All the way around would have been 10 pi over 5. This angle is 9 pi over 5. So what's left? 1 pi over 5. See, now that was not so bad. You got this. All right, let's do another one together. 2 pi over 3. So, and if you don't have to rewrite everything in terms of pi, that's fine. Then just go do it. But because we're over 3, I'm going to write this as 3 pi over 3. If I went all the way around, it'd be 6 pi over 3, but I don't really need to because 2 pi over 3, halfway between 0 and 3 pi over 3 would be 1.5 pi over 3. That's a point. So my 2 pi over 3 is going to land here. My reference angle is equal to what? If this is 2 pi over 3 and all the way is 3 pi over 3, what's left in between them? 1 pi over 3. Okay, not so bad. Give the last two a try. You can do it. All right, 5 pi over 4. So pi would be 4 pi over 4. 2 pi would be 8 pi over 4. Halfway in between those two would be 6 pi over 4. So 5 pi over 4 has got to be between the 4 and the 6 right here, giving me a reference angle right here. If this is 5 pi over 4 and that's 4 pi over 4, what's the difference? 4 pi over 4. Can you do it with the negatives? I bet you can. Okay, so just going this way, this is still negative pi, so negative 12 over 12. All the way around to be negative 2 pi. Halfway between 12 and 24 is 18. So the 17 would be not quite all the way to the 18, right about here. My theta hat between that terminal ray and the x-axis. And if I went all the way to 17 pi over 12, past the 12 pi over 12, how far past did I go? 5 pi over 12.